Good, good morning. First of all, I hope that you are doing well in these circumstances. I would love to tackle the second topic related to the functional programming paradigm. We will be talking about types in general. Now, let me go briefly to talk about types. We have already seen that in several programming languages that we addressed before, like Java, Python. In this case, if you think about actually a type, this is just actually a name of a group of related values in this case. Let's think about natural numbers. In Java, we have, let's say, the data type integer. And if you want actually to deal with integer, you are having four different names actually for this data type. And depending on the size of the number that you want to deal with, you will be selecting actually the most appropriate one. Thus, there is actually a name which is an int. Once you choose int in Java, then in this case we are dealing in total with 32 bits, meaning actually the number that we'll be storing will be a number in the range between -2 to the power of 31 and 2 to the power of 31 minus 1. Now, however, if we want actually to deal with numbers bigger than 2 to the power of 31 minus 1 or smaller than -2 to the power of 31, then we have actually to go to 64 bits. In this case, we will use the name long. Okay. Sometimes we have problems that deal with smaller numbers, thus we can actually go for short. Then in this case, we can store, let's say, our numbers in 16 bits. And last but not least, if you are having applications dealing with numbers between -128 and 127, then most probably the byte data type will be the best one. In Java, there are different other primitive data types like Boolean, like floating point numbers. We are having also character. These are the primitive data types. Last but not least, there are, let's say, some data types that are complex actually data types like string or arrays. And at the end of the day, you can actually define your own data types in this programming language. Now, so far, dealing with the functional programming language Haskell, we haven't actually talked about data types a lot. However, in Java, the first thing we have actually to do is just actually to deal with, let's say, data types. Now, I will just actually recall some examples. I want actually to declare a variable where variable is equal to 5. Okay, now, if you will compile it, Java will not accept it. Okay, why? Because actually Java expects actually from us, okay, to declare the variable before using it. Thus, in this case, what I want, I want actually to give it a value. Okay, first of all, I have actually to declare it. And last but not least, Java will accept it and it doesn't have actually any problem with it. Thus, Java at compile time, okay, need actually to see, let's say, that the values in this case are used correctly with their corresponding data types. Thus, look, I will just actually give you, let's say, an example. If I want actually to have, let's say, int r, okay, and in this case, what I want to do is I want actually to take an x and store actually in this variable x, I concatenate x with CSEN. Now, look, at compile time, Java will tell me I'm having a small problem. Okay, the problem is actually the following. This is at compile time. Okay, the problem is the following. If you want actually to concatenate an integer with the string, this is actually possible, but you can only do it if the variable that you want actually to store in has a data type which is a string. Thus, at compile time, Java checks actually that. Now, in this case, we will be talking about a statically typed programming language. The meaning of statically typed programming language is that at compile time, Java will check whether actually the use of the data types with the variables as well as the operation is done actually correctly. Now, let's go and jump actually to Python and see, let's say, what kind of type Python is having. Now, I will do actually the same. However, in Python, you will write actually only x equal to 5, and you do not need actually to define the data type of it. And what Python actually will do is it will just execute it will just infer the data type depending on how we are actually using the variables in this case. Now, let me write actually the following. I will print x, and last but not least, what I want to do is I want actually to define a variable r that takes x, and it just actually concatenate actually to it CSEN. Without actually defining actually the data types, I started debugging. Now, let's look at what will happen in this case. Now, actually, the program at runtime will get actually executed step by step. I will be printing the x, okay, and the x actually will be printed and will be displayed. However, once I will go further, you get actually a problem. At runtime, I'm having actually a problem that, let's say, the addition of an integer with the string in Python is not allowed. Okay, thus the programming language is dynamically typed, meaning at runtime the check actually is performed. In a statically typed programming language, the check will be done at compile time in this case. This is actually the first, let's say, way how you can classify languages, programming languages. There are programming languages that are strongly typed, okay, statically typed, and there are other programming languages that are, in this case, dynamically typed. Python is an example of a dynamically typed programming language. Okay, Java is an example of a statically typed programming language. Haskell is a statically typed programming language in this case, as we will see later. Now, let me actually go further and let's try actually to do the following. I will be declaring a variable x to be equal to 5. And afterwards, I will just actually change, let's say, the variable to have actually as a value a string. Okay, now what I need actually to do in Java, since I'm changing actually the data type, I will try actually to declare the variable now to be of type string. Now please actually look what I'm doing. I'm having the variable x and I'm declaring it twice. Once I will do it, Java will complain and it will tell you, I'm sorry, you have already declared the variable x to be of type integer and you cannot actually change its data type. It's impossible because it has been already actually defined to be an integer. It remains actually till the end actually to be an integer in this case. Thus, the programming language is not only statically typed, but it's also a strongly typed programming language, meaning whenever you define a value, okay, to a variable to have a specific data type, okay, you will not be able actually to change it while you are actually writing your algorithm in this case. Now the question is, how will it look like if I think actually about Python? Now I will do actually the following, and what I will do is I will write x is equal to CSEN. Okay, and last but not least, print x. And look, once actually I will run it, okay, Python will not complain. Why? Because Python is, in this case, a weakly typed programming language. Okay, and the meaning of weakly typed programming language is that I can just change actually the data type of the variable while actually I'm running actually my algorithm in this case. Okay, now just actually going back to Haskell. Haskell is a statically typed programming language, and it's at the same time a strongly actually typed programming language. However, actually till now we didn't actually deal with, let's say, data types at all. Okay, that let me write actually something of the following form. Add of xy is equal to x plus 1. Okay, thus what I will do is I will actually compile, and what I will do is I will actually load my file. Now I will be having actually an add, okay, that will perform actually the following operation. It's actually the addition of two values, and I really do not know exactly what is actually the type of the two values because I haven't specified them, and that's why I will be trying everything. Now I will be adding 3 and 4, and what will happen in this case, Haskell will tell me, okay, I can perform the addition of the two numbers, and the result will be in this case 7. And then I will go further and I will do it with 4.2 and 6. Now I'm having an int as well as a floating point number. The question is, will my program, the same function that I implemented, will it actually handle this case, yes or no? And in this case you get actually a correct result. Once you have a function that will perform the operation on different types, we will be talking about actually a function which is a polymorph function. Okay, now the question is it possible to take CSEN and actually add it with hello? Okay, thus once actually I will do it, I will get an error. Okay, and it tells me actually the following: you will not be able actually to perform the addition of two strings. Okay, that's the plus, the operator plus is not actually defined to do that. That's the question is, what is the type of add? Okay, that's what I will do is, I will write colon T add. This gives me actually the data type that will be inferred automatically by Haskell. And in this case, it tells me the A is of the following type. It takes as a first parameter X, okay, and A, and the A is a numeric value. And the meaning of a numeric value is a class of data types, okay? Thus, an integer is a numeric data type, a floating point number is a numeric data type, however, a string is not a numeric one. The first argument, which is the X, is of type A, which is a numeric value. The second one is of type A, which is a numeric value too. And last but not least, the result will be of, let's say, data type A2. Thus, please keep in mind actually this notation, and I will explain it later. Let's say why it is actually written as A implies A implies A. Now, most probably in the first lecture, you dealt actually with, let's say, something of the following form, and you saw the difference between actually both of them is equal to X plus Y. Now, the first question is, does Python accept overloading, yes or no? And apparently it doesn't, and that's why what I will do is I will go and actually give it a new name, which is actually add2. Thus, now once I will load, I will be having actually two methods, okay, two functions. One, okay, that once I want actually to use it, you have actually to give it as a parameter a pair, okay, of two values, 1 and 2, and this one actually will give me as a result 3. And once I will ask about the type of add2, the type of add2 is the pair, okay, which corresponds actually to X and Y. It's written actually between brackets, okay, and this is actually one argument, and in this case the result will be actually of the same type, which is a numeric data type in this case. Thus, the difference between actually these two functions, we will look at them later in more details. The first add function is a curried one, meaning I'm not using actually brackets, and the second one is a non-curried one. In this case, I'm using actually brackets in this case. Now, we have actually to get used actually to it, that most of the functions that we will be implementing should be actually functions that are actually curried actually one, and it has many advantages, as you will see later. Now, let me go further and talk a little bit about data types. Now, the question is, if I want actually to know the data type of 6, okay, what Haskell will tell me is that 6, okay, the data type of it is A. It's just actually a variable, and A is just actually of a numeric type, okay. However, once I will write the type of, in this case, 9.2, I knew 9.2 is not any numeric value, but it should actually belong to a subclass of the numeric value, and in this case it tells me, okay, the A is a fractional one, okay. Fractional A is just actually to define the type of the A, and the 9.2 is of type A, which is actually of fractional one. Now, you have actually to know, if I want actually to do the following, and I will be having CSEN, then actually this one is a string, okay, and Haskell actually will infer actually that the data type of this value, this literal, is a string in this case. Okay, now the question is it possible that actually the user will define its own data type? And the answer is yes. Okay, we can do that. Now, look, what I have here is something of the following type. Add is of type A to A to A. That means actually the first argument is of type A. The second argument is of type A. Both of them are of numeric value. And the result, once I perform the addition, is of type A, which is actually of a numeric value. Now, what I want actually to do is to define actually the following. An add, and I will give it actually my own type. And then I will say from int to int to int. Okay? Thus, whenever actually I will do that, and I will compile, now, Okay, well, I will load. What will happen in this case, once I will go and add 8 and 9, okay, Haskell will not have any problem with it. It will perform actually the addition. Why? Because it sees that A is of type numeric and it's of a specific type, which is an integer. Okay, the 9 is of a type which is a numeric value, and it's actually an integer in this case, and that's why the result actually will be performed in this case. Now the question is, what if I am having add 9 and 2.1, and what you will get actually as a result here is an error. I'm sorry, okay, you defined actually the type to be from int to int to int, and that's why the addition of an integer with a fractional will not actually work anymore. Okay, thus usually what we do is we keep actually, let's say, the call actually for Haskell to infer the data type, because Haskell will be always trying actually to infer the most general data type. However, if you want to restrict the application of your function for specific data types, then you can actually do it yourself. Okay, thus this is, let's say, in brief about, let's say, the data types in Haskell. Now let's implement actually a function which is in this case a recursive one. We have already actually done it before. Factorial of 0 is equal to 1, and the factorial of x is equal to x times factorial of x minus 1. Okay, now once I will apply this, once I will load my program, and I will call it with factorial of 10, and then in this case you will get actually a nice result. Once I will do it with factorial of 200, do it in Java, then you will see actually what kind of problem you have. Once I will do it with factorial of 3000, what you will be getting here is you will be getting a huge number in this case, and that's why the question is, what is actually the size of the data types in general? Okay, therefore I will be going just actually to give you an idea about, let's say, the different data types I have. Okay, there is actually an unbounded integer numbers, which is actually the integer 1. Okay, however, once I will be dealing with an int data type, in this case I will be actually dealing only with numbers that are actually, that can be stored only in 32 bits. Then there is actually the rational data type. It's an unbounded one, which is actually the default one. If I want actually to change it and use float or double, then you will be having either a single or a double precision floating point numbers. The Boolean values are actually, in this case, of type bool. These are actually the built-in data types, and then actually there is also a data type character, which is actually characters. The string, it's nothing else than a list of characters in this case, but we will actually tackle actually this problem once actually we reach it. Now, what does it mean? It means actually the following. If I will ask about the type of factorial, okay, then I know exactly that I will be performing operations on the x, like multiplication of x times actually a value. And then if I have x, then I'm subtracting actually 1 from it. And then Haskell is smart enough actually to deduce the following. It tells me, okay, it's the function is of type A implies A. However, the A can only be of a numeric value, meaning you will never be able actually to call the factorial on, let's say, a string in this case. Okay, Haskell will be having actually a problem with it. Now the question is it possible to change actually the data type of the factorial? That's what I will do is the same thing. I will go and write factorial of int, okay, implies int in this case. Okay, now once I will do it, let's try actually to run it. If I have actually the factorial of 5, I should get 120. If I have a factorial of 200, okay, what you will be getting here is you will be getting a 0. Okay, you will be asking yourself, why actually am I getting a 0? Because actually in this case you redefined actually the data type of the factorial to be more specific than the data type that was inferred by Haskell. Thus in this case the factorial is of type int, implies int in this case. Okay, this is nice. This is actually really amazing that you are having a programming language. Okay, and just actually for your information, Python will do actually the same. It infers the data types automatically. You really don't need actually to define the data type yourself. And Haskell is also a declarative programming language. Okay, and it's a typed programming language in this case, and it has a strong engine to infer data types in this case, as you saw actually before. Now, let me go to the add of xy again. Okay, it's equal to x plus y. Okay, now we will be talking actually about the data types. Okay, I will be writing actually a comment. Okay, in Python and Haskell, actually the comment are actually the 3 dashes. Okay, you take a look at actually the A. Okay, that's if I will ask you the following, the add, how many parameters does it take? Okay, then actually some people, if they look at this one, because actually if you go to Java and you have actually to implement a function, the function will be a static one, it returns an integer and it performs the addition, then I know exactly that with this function or this method will be taking actually 2 parameters, x and y. And what it does is it returns actually in this case x plus y as a result. Okay, thus in this case, once I have it, then what I can do is I can actually call it system.out.println, and then I will call the addition of 3 and 8. Okay, thus in this case, once I will compile, the program most probably will compile correctly. Once I will run, I'm expecting 11 as a result, and you get actually 11 as a result. Thus, please actually look at this one. Thus, in Java, we will say that the add method is taking actually 2 parameters, x and y, and it returns actually a value, and the value is of the same data type, which is an integer in this case. Now, you have actually to get used to a different, let's say, terminology in Haskell, because in Haskell, any function that I am having will be applied only on one single, let's say, argument. Okay, that's the add is taking only one argument. But what it does actually return is, it's a function. Okay, thus in this case, I will be writing a, and then in this case, it returns actually a function that takes as a parameter another a, and last but not least, okay, the whole thing will be giving me the same value a, where the a is of type numeric in this case. Okay, thus look, once I will, let's say, run it, and then I will ask about the type of the add, you will be getting actually the same thing, where the brackets are removed. That means you really do not need actually to see the bracket, because actually the whole thing, okay, by definition is left associative. That means in this case, the add takes as a parameter an a, it returns a function, the function takes as a parameter a, and the whole thing actually would be returning a, well, a is of numeric value. Okay, now look, I will just actually do it, let's say, further with the following example. I want actually to perform the addition of x, y, and z. Thus the whole thing will be x plus y plus z. Now the question is the add. How many parameters does it take? It takes only 1, and the 1 is of a numeric value. Okay, now what does it actually return? It returns a function. The function takes 1 parameter, and last but not least, which is actually the y, and it returns a function, and the function takes 1 parameter, and what it does is it returns actually a value which is of the same data type, 1, 2. Okay, thus in this case, once I will go and run, reload actually my algorithm, and I want actually to perform the addition of 5, 6, and 7, the result will be 18. Thus actually the operation will be performed, and the question is, what is the type of the add now? Okay, thus what you will get as a result is the same thing. However, actually all brackets will be removed, because you have actually to understand it as follows. The add will take actually 1 parameter, which is the a. It returns a function, okay, that will just get another argument. This is actually the y is of type a. And last but not least, the whole thing actually will return a function that expects an argument, in this case it's the z, and it returns actually a value, and the value is of type a in this case. Thus again, what will happen in this case, okay, you will just actually remove the whole brackets, and this will be actually the data type of the add. Now what you can do is you can actually do the following. You can change it. Okay, you will say I will have an int, I will have an int, I will have an int, and last but not least I will have an int. Okay, thus now what will happen in this case, once I will load and ask about actually the data type of the add, okay, Python will stick to your implementation, to your definition, to your data type of the add. It tells you, okay, the data type of add is int. It takes as a first parameter int. It returns a function that expects a parameter, one parameter, which is of type int. It returns another function. In this case, the z will be actually the parameter of this function, and last but not least, the whole thing actually will return a value in this case. Now, keeping in mind, if I want actually to perform the addition of 5, 6, 7, this one will work. Anyone who wants actually to do it with 567.0, okay, now Haskell will be having a problem with it. Why? Because in this case, the data type 7.0 is of fractional data type, and the fractional data type is not a subclass of integer, and that's why the whole thing actually won't work in this case. Okay, good. Now, let's go further to a topic which is related to defining actually our own data type. Okay, that's we talked about, let's say, data types in general. We talked about the way how you can change the definition of the data type, and sometimes what we want actually to do is we want actually to define our own data type. Okay, thus there are actually two ways how this can be done. There are two keywords that we have actually to get used to it. The first one is just actually to rename existing actually data types. Okay, thus in this case, what I want actually to do is to define, let's say, a pair. Okay, and the pair will define actually something that I will define in my example to be, in this case, point. Okay, thus the point will be, in this case, let's say a pair, and you decide about actually the data type of the values in this case. Thus I will be having int and int in this case. Okay, thus now I'm having actually a new data type, and what I want to do is I want actually to get the x coordinate of the point in this case. Now what I can do is, since I renamed actually the pair, okay, int actually to a point, I can actually say the following: it's point. Okay, that goes actually and it gives me actually an integer in this case. And the get x, once I will want actually to define it, it will be defined as follows. Since I'm expecting actually a pair in this case, I will be having x, and here an underscore because I don't care about actually the value of the y in this case. And then what you will get here is an x. Now, once I will compile, and I will just go and reload, okay, then in this case I can go and ask about let's say the x coordinate of a point, which is actually 1, 2. What you will be getting as a result is 1, 2. Now once you ask about the data type of get x, okay, in this case you see exactly actually what kind of data type it has. It's actually of type point, implies int, because actually this is the one that I defined. If you don't have that, the question is, what will, let's say, Haskell infer? Okay, I'm sorry, it's reload. What will Haskell infer in this case? Okay, if I will go and get actually the x, it tells you, okay, in this case I will not actually apply it on the point, but in this case I will apply it on any pair. Okay, and in this case the get x can be applied on the following. If I have 4 and I will be having CSEN, then in this case the get x actually will work perfectly. Now look, once you go here and you add actually the data type, now you are restricting the use of the get x. Once I will go and load, and once you ask about the data types of x, it tells you it's actually of type point, implies int. I know exactly that the point is of type int, comma int. It's a pair, and that's why once you will go and you do it with get x of 4 and CSEN, the 4 is an int, however the CSEN is a list of characters, is a string, okay, and that's why Haskell will not accept it, and it will actually give you an error in this case. Okay, now the main idea of using the type is just actually to avoid having actually something of the following form where the user will be having here something like int, okay, it's just a predefined one. This one actually will do the job too. Thus in this case, once you load, once you have the get x, let's say with 1 2, you get actually 1 2. Once you ask about the data type of get x, it tells you from int to int. Okay, thus the type is there just to redefine existing data types the way actually you want. Thus again, if I want actually to define a point, okay, and the point is equal to, in this case, a pair, and the pair is first argument is of type int, the second argument is of type int. In this case, what I need actually to do here is just actually to state it here and use, let's say, the defined data type that we have, okay, and in this case everything will work perfectly. Okay, the get x will be of a function that expects point as first argument, which is in this case a pair of int, and last but not least, it returns actually an integer in this case. Okay, this is actually the first thing. Okay, the first, let's say, possibility how to define a type, which is actually in this case renaming existing data types. You can actually do it with, let's say, type. Now the question is, what if I want actually to define a new data type, which is called fruit? Okay. And the fruit could be either banana, orange, or, okay, you are using actually, let's say, the bar, or kiwi. Okay, now can I do it actually with the keyword actually data type? You will go and you will load, and what you will get here is an error. Thus, if you want actually to define something which is not actually redefining existing actually data types, the word type won't actually work. The question is, can I do it with data? Okay, I will do. Okay, and what I will do is I will reload, and in this case Haskell will tell me, okay, it's nice, okay, now you are having actually a new data type that I am defining. Just actually for your information, this is actually the name of the data type, and this is nothing else than actually a constructor. The constructor is called banana, it's orange, and it's kiwi. And you have to take care. There is actually a kind of convention in Haskell, and you have to stick to it. Anything that you have actually to write, okay, the data type itself, as well as, let's say, how you are defining, let's say, the different, actually, in this case, fruit, you have to do it with uppercase. If you don't do it, look at what will happen. I am changing now with kiwi, let's say, to lowercase k, and that's why this one actually didn't actually work. Now the question is, I want actually to know the color of a fruit. Okay, thus I will have fruit, okay, or I want actually to check, let's say, the let's say is color, okay, and this one actually will give me a Boolean value. Okay, thus the question is, I want actually to return, in this case, true if the color is yellow, otherwise I want actually to return false. Okay, thus I will define something of type is color. If it is banana, then in this case the whole thing will be equal to true. Okay, and then if you have, let's say, anything else, then this one actually will be false. Okay, now let's actually try it out, and then actually let's see where the problem are, and then actually we'll fix them one by one. Okay, first of all, this one actually has to be of type bool. Okay, thus there is no constructor actually called boolean because the default one is bool. Now once I will do it, it tells me actually this one has to be true and false, and they have to be written actually in uppercase because actually this is how it is actually defined in this case. Now you load and everything will be perfect. Thus let's take a look at what we have here. We have actually one, let's say, data type which is called fruit that I'm defining, and this data type is an enumeration of three different actually data types: banana, orange, and kiwi. And last but not least, I want actually to define, let's say, a kind of a function that takes as a parameter a fruit, and it returns actually a boolean value, and the boolean value will be true if the color is, in this case, yellow. Is color yellow. I can just write it down here. Okay, is color yellow. Okay, and that's why I will just actually define this one with is color yellow. Thus it's actually a boolean function. Okay, and it returns true if the fruit that I'm dealing with is banana. Otherwise it will return actually false in this case. Now the question is, how will I be able actually to use it? Okay, we will go actually one by one. We will actually do is color yellow. Okay, and you will ask actually the following, banana, and what I will be getting here is I will be getting true. Okay, and what you will write here is you will write actually kiwi, and then in this case you get actually false. You write in this case orange. Okay, thus orange is not yellow, and that's why what I will be getting here is I will be getting actually false. Nice, it looks actually really nice. The question is it possible actually to do it with, let's say, apple? Okay, the question is, did I define actually the apple fruit? Yes or no? I didn't define it, and that's why what you get here is it gives you an error. I'm sorry, the constructor apple is not defined because I don't have it actually here. You can actually change it. Okay, you can actually add an apple. Okay, and then actually what will happen in this case is the following. Once I will go and load and call is color actually apple, in this case the whole thing will change because, okay, this one actually means the only let's say fruit that is having a color yellow is banana. In this case anything else actually will be false. Okay, now let's go further. What we want actually to do is we want actually to define a new data type. Okay, and the data type is similar actually to the one that we defined in Prolog using a structure, which is natural numbers. Thus I will define actually something of type nat. This is actually the name of the data type, and then I have actually two cases. The first case is either 0 or is the successor of a natural number. That means in this case I will do actually a kind of an inductive definition of a data type. It looks nice. Okay, thus in this case any function, if I want actually to define, let's say in this case 1, I will define it with successor of 0. Okay, if I want actually to define, this corresponds to 1. Okay, if I want actually to define 2, okay, the 2 actually will define in this case as successor of 0. Okay, and so on. Okay, now again, this one actually means it's a comment. And now what I want actually to do is I want actually to perform the addition of two numbers. Okay, thus it's an addition. I have actually to look whether I have an addition here. I don't. Okay, thus it looks nice. Thus what I want actually to do is I want actually to perform the addition of two numbers, and now depending on the implementation that I have, okay, I will be having add of 0 and y. The question is, if I add y, a 0 actually to y, what will be the result? It will be y. And now the second actually case is, if the first value is not of the form 0, then actually most probably it's of the form successor of x. And in this case is equal and y in this case. Now the result has to be for sure having, let's say, the successor constructor. And then what I will do is I will take actually the addition of x and y and perform it actually recursively in this case. And that's why now here you read it as follows. addition of the successor of x and y, which is x plus 1 plus y, is equal to x plus y plus 1. And this is exactly what you see here. It's a successor of an addition of x, y in this case. Now, once I will save and I will load, let's take a look at what will happen. Okay, if I want to check the data type of the add, it tells you the following. Okay, automatically it will infer the data type actually for you. It tells you just by looking at this one. Okay, I see that actually the addition, okay, now let me comment. The addition is having as a data type NAT. This is actually the first one. Okay, now the second actually one will be, in this case, let's say the Y. Okay, that's the Y. Okay, you have actually to know exactly its data type. You have actually to know exactly how you will reason. Just by looking at the first one, you will not be able to infer the data type of the Y at all. Why? Because actually this Y will be added to 0 and the whole thing will be equal to Y. And that's why I cannot actually have anything, let's say, that tells me about the data type of the Y just by looking at the first one. Now, let me go further to take a look at the second line, the second definition. If I go to the left-hand side, add of successor of xy confirms that the first one is of type NAT. However, the y, I really don't have any idea about it. Okay? However, by looking at the result is of the form successor of something, and the successor of something can only be a natural number in this case. Thus, I know exactly that the data type of the result is of type NAT. Now, I'm still actually missing actually the data type of the y. Okay, now look what I will be having. I will be having a function that returns a y here and a function that returns successor of add of xy here. And the engine is strong enough actually to say that the data type of this y has to be identical to the data type of the return value, meaning this one can only be of data type NAT implies NAT implies NAT. Okay, thus the question is, let's try it out. I will have an add of 0 and 0. Unfortunately, you don't get actually a result. Why? Because here I am having as a result actually something which is defined, which will be returned as a value in the form of the data type that I am defining. Okay, thus what you need actually to do is you need actually to add something called deriving show. Thus in this case you will show, okay, it's a function in this case, and you will show the value, okay, that I am having that can be, let's say, transformed into a string and displayed actually on the screen in this case. Now look, once I have that, okay, and nothing will change. If I ask about the type actually will remain the same. However, now actually once I will perform the addition of 0, 0, okay, the deriving show will allow you actually to display, let's say, the information about the result in this case, and it will be displayed as a natural number. Now the question is, what if I am having a successor of 0, okay, and I will be having here a successor of 0, okay, 1, 2. Now the first one actually corresponds to 1, the second one corresponds to 2, and the result actually should be in this case 3, and you get as a result 3, which corresponds to the successor of 0 in this case. That means actually the addition actually will be performed correctly, and the result will be stored into the form of the data type in this case. Okay? Thus, here you can actually perform, let's say, several operations. You can think about, let's say, a function that will convert the structure, okay, let's say, data type, the successor of 0 to 2. The question is, how can I define it? Okay, I will call it actually, let's say, NAT to number, okay, of 0. This one actually will be equal to 0. Okay, now nat to number. If it is not of the form 0, then actually it's of the form successor of x. Okay, and now what I will do is I will define it actually as follows. It's equal to 1 plus, and then nat to number, in this case applied only on x. Okay, and I will not actually define the data type in this case. Okay, we will just actually compile, and then actually we run it with nat to number, in this case, okay, of successor of 0. And what I will be expecting as a result in this case is a 2, and you get as a result 2. And that's why look actually what we had actually before. What I can do is I can write nat to number, and then I will actually perform the addition of the whole thing. Okay, and once I have it, I want, let's say, to display actually the result in this case, and it gives you 3 because the addition will give me successor of 0, and nat to number will give me 3 in this case. The question is, let us actually think about a nat to number, in this case data type. Okay, it's really an easy one. You have actually to look at it actually one by one. You take a look at actually this one, how many parameters does it expect, since actually it's a function in Haskell, it expects only one parameter. Okay, thus the first one is 0, and 0 is of type nat. That means in this case it's nat implies actually something. Okay, that's the second one, has to be, the argument has to be of type nat, otherwise actually I will be having a problem. And then you will be getting 1 plus actually something. Okay, and this one can only be of type, let's say, either int or any numeric value. Now what I will do is I will write it actually with int. Okay, with int. And now what I will do is I will go, okay, and I will load, and last but not least I will ask about, let's say, I will just actually call it with nat to number successor of 0. You get actually as a result actually 2. And the question is, what is the type of nat to number in this case? Okay, what you will be getting here is actually the data type that I defined actually myself. Now I will comment it. Okay, now Python, either actually it will give you the same data type that you defined or a more general one. It will never actually give you a more specific one. Okay, and that's why once I will go and load and now ask about the type of number, it tells you, oh, I can do better. Okay, now the question is why? Because here you are actually performing an addition of 1 plus something, and this one actually Haskell will know exactly that the addition that will be performed, okay, is performed on numbers when numbers are of numeric value, and that's why it gives you a more general one, which is nat to a, where a is of a numeric value in this case. Okay, now let's go further to another data type, which is about lists. Okay, now let's do it in English. A list is either empty, like we did actually before in Prolog, or if it is not empty, it has one element, which is the head, okay, and a remaining list, which is actually in this case the tail. Okay, thus what I'm defining here is, okay, is, let's say, a definition of a list and a recursive one. A list is either empty or it has one element, which is a head, okay, and a remaining, let's say, list, which is actually a tail in this case. Now the question is, how can I define it? Okay, I will define actually the the list. Okay, and the first question that I will be asking actually myself is, the list, what kind of elements, what is the type of the elements that I will be actually having in this case? Now, if you wanted actually to have a kind of a polymorph one, meaning you can have a list of integers, you can have a list of floating point numbers, you can have a list of anything, then you will do it actually with list A. Okay, thus list A means that I will be defining now a data type list And the data type list will be having things of type A in this case. Now, let's go and do it one by one. The first one is that the list is an empty, it's nil. Okay? We did actually almost the same in Prolog, defining actually structures in this case. Now in Haskell, I will be having, let's say, a second possibility in this case. If it is not nil, it will be of the following form. It's cons, it's a constructor that I will be actually defining with cons. I'm constructing a list that has a head, it's an element. What is the type of the head? Is A. And the tail is a list, and the list has to have the same actually type of element, which is actually of type A in this case. Okay, nice. And then what I will do is I can actually think about, let's say, different functions that I want actually to define. I will define the length of a list. Okay, yes, I will call it length 2. And if I have a list, if it is nil, then I know exactly the length of it is 0. If I have, let's say, a list which is not empty, it's of the form cons of xy, where x is the first element and the y is the result list. Now the question is, how can I define, let's say, the length of the list? It's 1 plus, in this case, the length 2 of y. Okay, thus what I will do is I will calculate the length of the result list, okay, and I will add 1 to it. Thus in this case I really don't need actually to have the value of the x at all. Okay, why? Because at the end of the day I will get it and I will perform actually the operation on it. Okay, and last but not least, once I will compile and I will go and run, let's say, this one with length 2 of nil, I will be expecting 0 as a result, and you get actually 0. If I have the length of a list is cons of 1, cons of 3, cons of 4, and nil, in this case 1, 2, 3, I will be having 3 elements. That means you will be getting as a length actually 3 in this case. You have to take care, since I will be having, let's say, something that is of type A. In this case the list is a homogeneous one, meaning you can, if you want actually to have a list that consists of any type of element, since actually I'm using the list A in this case, this is not possible because all elements, they have actually to have actually the same data type in this case. However, if I will take actually this one and I will do it actually with, let's say, 9.2, okay, this one actually will work because the 1, the 3, and the 9.2, all of them are numeric values. Thus actually in this case all of them will be of type fractional, and this is actually something that will actually work out correctly. Now the question is, if I want actually to sum up actually the values of a list, how will I do it? I will actually do it the same way. If sum of nil will be equal to 0, and sum of I will go actually to the data type in a few minutes, but actually let's go to the sum of a list that is having cons of x and y. Okay, that the whole thing will correspond to x plus, and then actually sum of the y in this case. Okay, thus once I will compile, if I will run it, okay, an ambiguous variable, okay, I will call it sum2 because actually the sum is predefined in Haskell, and that's why I cannot actually overload. Thus I will go here, I will just actually compile, and now if I have sum of 2 of nil, this one actually will give me 0. Sum of 2 of a list that is having cons of 1, cons of 22, and then cons of minus 2, okay, or let's say 1 and nil, 1, 2, 3, then in this case what you will be getting here is 24, which is actually the addition of 21 plus 1 plus 1 in this case. Now let's go actually to the type of length. Okay, now I will do actually 1, and I will see actually what Haskell actually will generate. Okay, length 2 could be actually of the following type: nil, meaning actually this one will be of type list. This is actually for sure. Okay, and last but not least, okay, if I take a look at the result, this is 0 and this is 1. That means I can actually do it of type integer in this case. Now let's take a look at what Haskell will generate once actually I will go the length 2 in this case. Okay, now it tells you the following. It's list B, meaning actually any data type, meaning it's actually a list of type actually B or of type A. Okay, and this one is of type integer. However, actually here we did it actually of type integer. Okay, Haskell will do it actually better because it tells you, okay, the A is of any numeric actually data type in this case. Okay, if I will just actually define it now to be of this form. Okay, and now I will go and load and ask about actually the data type. Then the data type has been changed actually to the more specific one because I'm using here actually the more specific one in this case. Okay, thus it's up to you which one you will use. You can always actually rely on Haskell. That will give you actually the most general one in this case. Okay, now let's go to the sum. Okay, the sum is actually the following actually thing. Okay, however, you have actually to take care because actually the sum is a list. Okay, and the list could be a list of integers, okay, going actually to integers in this case. Okay, now let me comment actually this one. Okay, or let's keep it. Okay, and go and load this one. Okay, and ask actually the sum 2 of the list that we had actually before, and it will work actually perfectly. And if you ask about the data type of the sum 2, then in this case everything actually will work perfectly. It's a list of integers. Okay, this is what I'm defining. Okay, and the result actually is an integer in this case. Now we have actually to take care. Whenever I will do it actually with 1.2, this one will not work anymore. Why? Because I defined actually the whole thing to be a list of integers and to give me an integer as a result. Thus I will be having actually a problem, but because 1.2 is not an integer at all. The question is, if I wouldn't have done that, what would actually, let's say, a Haskell generate for me? Okay, thus I will go, I will load, okay, and I will ask about actually the data type of, in this case, the sum 2. And what you will be getting here is actually the most general one, which tells you the sum 2 is of type list A, where A is a numeric value, and the result actually will be A, where A is of a numeric value. And that's why now, once you will do it with, let's say, any data type that belongs actually to the numeric, let's say, class, then this one actually will work. That's the result will be 24.2, and the result actually will be correct in this case. Thus, for now, I want actually to thank you. Thus, we are actually done with the second lecture about actually data types. We will proceed actually with, let's say, the data types part the next few lectures. For now, I want to wish you, let's say, health. Stay safe, stay home, and please try actually to practice, let's say, the things over and over again. Everything will be posted online on the MET website, and inshallah I will be seeing you soon live here at the Jam University in Cairo. Thank you and bye-bye.